All right, welcome back, everybody. There's going to be a small cut there in the video. I just had to take a breather to kind of catch up with my brain. So as you can see here, I've kind of changed up this Excel sheet that we were working with, and now these are represented in more hex format. Notice I've got those 0 X's up front, but don't get scared. This just means 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's all it means. If we come look at the code here, which I was testing with, as you can see, you'll notice that hex addresses always have that little 0x up front. So that's why I changed that. So now, as I said, bytes are represented by 8 bits. And so in each of these, there's probably 8 bits. 1, 2, 3, 4, maybe like that. 8 bits. And so a double is going to actually take up 8 of these bits. 8 of these bytes, rather. That'd be 8 times 8, so 64 total bits. And let's say it looks something like that. That's what it looks like in memory. And so what we do here specifically when we dereference this pointer is we're telling the runtime to go to this starting address. Okay, so this is where dpointer is. Dpointer is hanging out right here, and it represents this 0x00. And so we tell the computer to go look at this address, and we say, dereference me a double. Dereference me a double. And so it goes, okay, here's my first byte, second byte, third byte, fourth byte, fifth byte, sixth byte, seventh byte, eighth byte. All right, I've got all of it. Now let's convert it into a number and spit it out to the screen. As you can see here, wherever it was, maybe before I segfaulted here, it's 3.14. And so now the very next thing that I tell it to do is I say, hey, this is now an integer pointer. Please dereference it. And so the computer says, oh, this is an integer pointer, huh? Well, if that's the case, then I'm only going to take these 4 bytes. I only want these 4 bytes. And it's going to say, all right, 1, 2, 3, 4. Dereference that as an integer. And what do we get? Well, we get some different value. Notice that all of these are ignored. All of these are ignored. And then finally, as I did just before this, pretend I didn't put this stuff in here. So I was just kind of catching up with my brain. We're going to do a float, right? We're going to convert that to a float address, and we're going to say, hey, computer, give me a float out of these first 4 bytes. And it's going to say, all right, here you go. And whatever we get this value here. So really, addresses have a type. And the reason that addresses have a type is because the computer needs to know how far into the memory it should dereference. If it's the type of a double, it says, all right, I need to dereference 8 total bytes. If it's an int, I only need to dereference 4 total bytes. If it's a char, if it's a car, I only have to dereference 1 byte. 1 byte. What? So let's kind of play around with that. So notice here, I kind of started doing some arithmetic. We're gonna call this pointer arithmetic. And we're gonna start adding numbers. We're gonna start adding numbers to this pointer, and we're gonna look and see what's popping out here. So notice that this is the type of a double. This is a double pointer, right? And so if I save this, pull it into Bobby and run it. Oh, I lost my place. We're gonna see something. We're adding integers to an address. Now let me check where we are here in the notes. So we can add integers and subtract from addresses. Now I'm about to explain to you how that works. So I should have compiled it. Maybe I didn't. And if I run it, notice here that this is our addition. This is the series of additions that we did. Notice this is the very first number we started at. Now I added 1. Now what was that? What is adding 1 to an address mean? Well, it depends on the type of the pointer. So when we add 1, we will add the size of the variable that the pointer is holding. When we add 1, we will add the size of the variable that the pointer is holding. Now this will all come around. I'm sure we're getting sufficiently confused at this point. That's crazy. What does that mean? Well, notice that doubles are 8 bytes. So if we add 1, look exactly what we added to that hexadecimal address. We said, let's take this address plus 1, and the computer says, all right, plus 1 double coming right up. And so it adds 8 bytes. 8 bytes to the address. And then I say, give me 1 more double. Add 1 more, right? What did we say? We said plus 2. So the computer says, two more doubles coming right up. So it actually adds 16 bytes as we get to 0, 0. So you kind of see the F here. There's an F. If we add F to F, this is kind of where this pops in. Notice that the 9 goes up to an A, and then the remainder of the number is the same. So then we add 8 more bytes again, and then we add 8 more bytes again. And so I'll just show you what it looks like with an int. So we've got int I pointer. And I want it to be equal to some address. Maybe we'll just assign the same address of D pointer. Now it will be mad at me if I don't convert it, so I'm going to do that. And then I'm just going to run this same little bit of code here. And I'm going to show you that we're not going to add 8 bytes this time, but we're actually only going to add 4 bytes at a time. And so the computer is smart enough to look at the type of the pointer. It's smart enough to look at the type of the pointer and determine how much it needs to add to get to the next int or to get to the next double. Now, why does this have anything to do with anything? Why are you adding integers to variables? Well, it's how arrays work. It's how arrays work. And that's the most crucial thing about this chapter is we're learning about dynamic arrays. And in order to implement an array, we need side-by-side memory. And so we're going to come up on that here next. And I'll show you exactly how that works. So let's see here where we're at. I would hope that these would be the same. But it looks like if you take 8 plus 4, you're going to get... If you take 8 plus 4... Oh, I see. I'm a goober. So why is that? Why are you doing that to me? So I'll recompile this code here. I'll give it a run. And so notice now that the int address here is the exact same as this double address here. But now as we add 1, if we add 1 to the double, we're going to add 8 bytes. But if we add 1 to the int, we're going to add only 4 bytes. Only 4 bytes. Only 4 bytes. And so now we enter the idea of an array. It's time for the array. So I'm going to come back to this here. I'm going to pretend that this is our array here. So let's pretend that this is an array for shorts. Now, not the shorts you wear in the summertime, but the type short. No, actually, let's not even do that. Let's do a char. Now, chars take up 1 byte worth of memory. And so each of these are a byte. And so if we had a character array, let's come up with a fun one. Maybe we do HELLOWORLD. Guess I want my 0x09 here. So here we have hello world. Now this is an array of characters where the H is stored here. Now what does an H look like? Well, if you're ever wondering, you can come to your ASCII table, roughly, and let's see roughly what an H looks like in a byte. So its hex representation is 48. So we're going to take 4. Now I got to format these cells, otherwise Excel is going to ruin me. 2, 3, 4, 5, 6, 7, 8. And H, if it's 48, it's going to be, I have to remember my hex, but I think 0100. I think that is 4, right? Because 1, 1, 0, 1, 1, 1, 0, 0. Okay, that's the 4. And then now we need the 8. So we're going to go up to 101, which is 5, and then 110, which is 6, and then I think this happens to be 8. So that is H. Now we can go look at E if you want, but you kind of get the idea here. That's represented as 4, 5, so that's pretty much the exact same thing. But it's 0, 1, 0, 1. So you kind of get the idea. We've got these bytes stored. And so let's make this character array. Let's see how we're doing on time. Well, we're going to come back to this next time. My brain's kind of fried at this point. I'm sure yours is too. So we're going to cut it just a little short today. Maybe I'll just kind of come through the notes here and just kind of reiterate what we talked about, so that when I come back on Wednesday, we can kind of have at least a general understanding of what we learned today. So for one, we talked about compiling with multiple files. We talked about header guards. And we talked about explicit conversions, right? The explicit conversions was kind of a big part of today, right, when I did this. And then we introduced a few operators. We introduced that ampersand, the address of operator, which returns the address of a variable. We also introduced the dereferencing operator, which kind of uncovers the value stored at an address. I showed you what the size of operator does. And then I told you about pointers, right? We kind of talked about the difference between static and dynamic variables. And then I introduced pointers, which are variables that hold addresses. And then at this point, I kind of started adding values to pointers. So we're going to pick up with that next time. So I hope you were able to follow. I hope you guys have a wonderful Wednesday. I look forward to seeing you. I guess have a wonderful Tuesday. I look forward to seeing you on Wednesday. Thanks for watching this video. And send me a message if you need.